going to talk a bit more about transformations. Suppose you wanted to graph f of x is equal to negative x squared. Now, we know how to graph f of x equal to x squared. You go to the vertex, which is 0, 0, and you go like this, and you're done. But what does this minus do? Well, if for some x value what I circled is 9, please, I did not circle x, circled x squared. So don't square x's. If what I circled is 9, then that's 9. So this f would be negative 9. If for some x value this is 11, then this would be negative 11, if possible. If what here was negative 12, then this would be positive 12. They differ by a sign. So, let's go to 0. When you negate 0, you still get 0. For this x value, it says go up that amount. For this function f of x, it says to go down that amount. For this x value, it says go up that amount. For this same x value, for the other f, it says go down. For this x value, it says go up that amount. For this x value, go up even more. For the first x value, go down a little bit. For the next x value, go down more. Basically, it's just going to be flipped over. It's just going to be flipped over. For example, if you were asked to graph f of x is negative x cubed. Well, we know f of x equals to x cubed goes like this. Go to the origin, go like this, and go like that. Don't forget to label your axes. Well, again, if this is negative 5, then this will be negative 5 or positive 5. They're always going to differ by signs. It's just going to be flipped across the x-axis. For this x value, instead of going up that amount, we're now going to go down that amount. For that x value, instead of going down that amount, we're going to go up that amount. That is what putting a negative sign in front of a function does. It flips it across the x-axis. It is the mirror image. The mirror image across the x-axis of this piece here is that piece. The mirror image across the x-axis of this is that. That is why this is negative x cubed. This is positive x cubed. This here is negative x cubed. What's in blue is negative x cubed. It just flips it over. Suppose you were asked to graph f of x equals not the square root of x, but negative the square root of x. Well, square root of x is drawn this way. You go to the origin and you go like that. And you say, done. Well, for negative the square root of x, you just do the mirror image across the x-axis. Imagine you put red paint along here, nice and heavy red paint, and then you folded the paper along that line, and you will now have red paint here. That would be negative square root of x. Negative the square root of x. It is the mirror image. So, what if we do harder problems? What if we want to graph g of x is equal to negative x minus 3 squared plus 4? Now, maybe first what you want to do is ignore, so let me just write down what we have. Don't want to write all over it. So maybe first you ignore the horizontal shift and you ignore the vertical shift. So what you're graphing is negative x squared, which just goes like that from the origin, the vertex. That's this graph. Well, the vertex here is same game as always. What makes that 0? X being 3. What does that say? 4. So what I'm going to do is I'm going to go to 3, 4. I'm going to go right here. And I'm going to draw an upside down U. And definitely I'm going to cross the x-axis, the y-axis. The question is, where am I going to cross it? And the answer is when x is 0. So we get negative 0 minus 3 squared plus 4, which is negative 3 squared plus 4, which is negative 9 plus 4, which is negative 5. Okay, so I'm going to cross at negative 5. Right there. I'm going to cross right here. So I go like this. It's a pretty narrow one. Where did I cross the x-axis? You may want to know. X minus 3 squared minus plus 4. That is what y equals or g equals. Now I want to know when y is 0. Okay, I want to know when y is 0. So I'll bring this piece to the other side as positive. X minus 3 squared equals 4. So there's only two possible values that x minus 3 can be. It can be 2, because when I square 2, I do get 4. And x minus 3 can also be negative 2. Just when I square negative 2, I do get 4. So x is 5 or x is 1. Okay. So 5 and 1. Maybe we should have found those first. But there's your graph. There is your graph. Let's suppose we want to graph f of x is negative 1 over x minus 2 squared minus 1. What we probably want to do is ignore the shift. We ignore the horizontal shift, we get x squared, and we ignore the vertical shift, the minus 1. So we don't get 1 over x squared. Now f of x equals 1 over x squared. It looks like this. So that's what that equals. Negative 1 over x squared is going to look like that. What's in blue is negative 1 over x squared. We just need to find our vertex. our vertex, it will be what makes that 0 is when x is 2. And what does that say? -1. Okay? So I go to 2, -1. 1, 2, -1. And I pretend that my origin is right there. -2, -1. Now, when I draw this blue shape, I hope it's very clear that I'm going to cross the y-axis. And that is when x is 0. So, we have that y is equal to -1 over x minus 2 squared minus 1. Actually, I do have one major problem here, and I apologize. It should be -1 like that, not in the denominator. That's a pretty big mistake. -1. Okay. So when I cross the y-axis, that's when x is 0. So y will equal to -1. 0 minus 2 is -2. I square it, I get 4 minus 1. Well, this is -1 1/4. It is -5/4. Okay, so if that's -1, that's -2. -5/4 is like right there. Okay, so it goes like this. Should have been a bit more curvy, but that's basically what you get. Gets closer and closer to the y-intercept. Sorry, closer and closer to this vertical asymptote. And there it is. There it is. Let us try one more of this type. Suppose you are asked to graph h of x is negative the square root of x plus 2 plus 3. Well, again, if you ignored the vertical shift, you would just get negative square root of x. And if you ignore the horizontal shift, you wouldn't have the plus 3 either. And negative the square root of x goes that way. Instead of, actually, that's not true. Instead of going that way, we go that way. Okay, so that's the type of graph we want to draw. But it's not going to be centered at the origin. The vertex is going to be what makes that 0 is -2, and what that says is plus 3. So I go there. I go to -2, 3, right there. And I want to come down and do this. Now, it could have been that the vertex would have been there and I just draw it because I'm not going to cross x or a y-axis. But in this case, I'm going to cross both. So let us find the y-intercept. That's when x is 0. So h of 0 is negative the square root of 0 plus 2 plus 3, which is minus the square root of 2 plus 3, which is 3 minus the square root of 2. Now, is that positive or negative? You should know that the square root of 9 is 3. And the square root of 9 is bigger than the square root of 2. So we just know that this is positive. So the y-intercept is positive. Okay. Now the x-intercept. That's when y is 0. So negative the square root of x plus 2 plus 3 should be 0. That is, the square root of x plus 2 must be 3. That means that x plus 2 must be 9. So x is 7. Okay. So we have a y-intercept at 3 minus square root of 2, and it crosses the x-axis at the number 7. Now, you may say, wow, this is pretty hard to draw. And I will agree with you. That's pretty hard to draw. So, what you do is, you come back, and all you know is you cross when it's positive. Okay? Now, it is your scale. It is your scale. You know, let me just draw the curve a little bit higher. It's your scale. Come back and draw it more friendly. Okay? Y-axis. So now, you can call that 7. And this is negative 2. And let's try to make that more believable. There's the y-axis. And it crossed at 3 minus square root of 2. There it is. Okay? If you have these 3 points really close together, it might be hard to draw. So I spread them out a little bit more. Put one point here, the other point there, the other point there. It's easier to draw. Okay. Now, just because maybe you can't draw it freehand, that doesn't mean you don't know how to do this. Doesn't mean you should give up. Just means the points, unfortunately, weren't friendly. Now, let us look at another type of transformation where I replace x with negative x. Now, if I tell you that f of x is equal to the square root of x, well then f of negative x will be the square root of negative x. That is, I'm just replacing x with negative x. So let us argue what happens. This graph goes, the graph square root of x goes like that. For this x value, when x is say 1, it says to go up that amount. Well, for this to be 1, now the square root of 1 doesn't depend upon how it became the square root of 1. If in there I let x be negative 1, then negative x will be 1, and I'll be taking the square root of 1. Doesn't matter how I come to take the square root of 1. I'm going to get 1. So when I plug in negative 1, I have to go up the same height. When x is 2, I go up that height. That is, the square root of 2 is that height. Well, If I let x be negative 2, then what goes in there will be negative x or 2. I'm gonna go up the same height. I'm gonna go up the same height I did there. In fact, it's gonna look like this. This here is the graph y equals the square root of negative x. It's just a reflection across the y-axis. It's just a reflection across the y-axis. That's what happens when you replace x with negative x. It's a reflection across the y-axis. And you need to study to figure out why this is true. Now, if you were asked to graph y equal negative x cubed, the way it's written like that, you may say, well, x cubed goes like that. So, and here is the y-axis, here is the x-axis, and when I reflect this piece across the y-axis, I get that piece. And when I reflect this piece across the y-axis, I get that piece. And that is why that is the graph of negative x cubed, where the yellow one is x cubed. Now, we've already drawn this function. This is the same as negative x cubed. That is, so when we think of it this way, it's the reflection across the x-axis. So instead of going down like this, we reflect across the x-axis and we get that. And instead of going like this for x cubed, we reflect across the x-axis and we get this piece. The same thing. You know, whether you write it this way or that way, since they are equal, you better get the same graph. Now, what about x squared? What about negative x squared? How do you graph that? Well, this here is x squared. This is y equal x squared. If I replace x with negative x, the graph is just a reflection across the y-axis. So instead of this piece, I'm gonna get this piece. And that piece used to be yellow. And when I reflect it across the y-axis, I get this piece. Oh, you mean I get the same graph? Yeah. What if you were to graph this function? Y is equal to the square root of negative x plus 2 plus 4. Again, if we ignore the horizontal shift and the vertical shift, it's just y equals the square root of negative x. And the square root of x goes that way, so the negative square root of x goes that way. The square root of negative x. All that's going to happen when we graph this one is we're going to have a different vertex, and possibly it will cross the x and or y axis. So let us work on that over here. You have y is equal to negative x plus 2 plus 4. And the vertex is always the same question. What makes that 0? The answer is x equals 2. And what does that say? 4. So I go to 2, 4. Go right here. And I want to go like that. Oh, you mean I'm going to cross the y-axis? Yes. And I cross the y-axis when x is 0. So y will be the square root of negative 0 plus 2 plus 4. Negative 0 plus 2 is square root of 2 plus 4. I'll say 4 plus the square root of 2. Okay, 4 plus the square root of 2. So here is my vertex. I go like that, and that point right there is 4 plus square root of 2. 4 plus square root of 2 is right there. Okay, we're gonna graph it just like we did the blue one. The question is where's the new vertex? The answer is it is at 2, negative 4. In terms of graphing, we are going to make believe that this is the y-axis and this is the x-axis. I go to the origin and I go like that. Now, I'm going to give you a graph of f of x and ask you to draw various graphs based on this. So f of x, say it goes just like this. Right here is negative 2. Right here is negative 4. Right here is 2. Right below that point is 3. And right below this other end point is 6. So those dashed lines are not really there. And I tell you that this is the graph of y equals to f of x. And I want us to graph f of negative x. The way you do such a problem is you find these key points. Maybe we'll even include that one. So we have negative 2, 0. We have 0, negative 4. And this height is, say, 4. We have 3, 4. And we have 6, 4. That point is negative 2, 0. 0, negative 4. 2, 0. 3, 4. And 6, 4. Now, these points came from f of x. Now, we want to talk about f of negative x. Well, for that to be negative 2, you have to let x be negative 2. And for that to be 0, you let x be 0. And for this in here to be 3, you let x be 3. And if you want x to be 6, you let what's in there be 6. Now, we want what's in here to still be negative 2, 0, 3, and 6. So, if I let x be 2, then what's in here would be negative 2. And I'll get back the same exact y value. 2, 0. If I want what's in here to be 0, well, I let x be 0 and I get the same y value. If I want what's in here to be 3, I let x be negative 3 because negative 3 is 3. And I'll get back the same y value. If in here I want it to be 6, I should let x be negative 6. Because when you compute negative 6, you get 6. So these are the key points for f of negative x. Okay. didn't make a mistake, but I left out one point. So let me try to fix that. Okay. -3. Now, oops. The point I left out was that point. 2, 0. 2, 0. So, it will be -2, 0. Now let's plot these points. Drew on that a little bit too much. Okay. So 2, 0, the first point is right there. It's right there. The next point, 0, -4, is also right there. -2, 0 is that point. -3, 4 is this point up here. And then -6, 4, kind of ran out of room, but -6, 4 is right there. Okay, so now when I draw this graph, I get this point, this line, this line, and that line. Those are mirror images. That's the mirror image across the y-axis. Okay, so that is the graph of f of -x. What if I want to draw the graph of negative f of x? What if I want to draw the graph of negative f of x? Well, for f of x, I have these points. -2, 0. I'm just copying these blue points here. 0, -4, 2, 0, 3, 4, and 6, 4. Those are the points I have. Now, I want to graph negative f of x. I'm going to keep the same x values, but the y values are going to have a sign change. When you change the sign of 0, you get 0. When you change the sign of -4, you get +4. When you change the sign of 0, you still get 0. When you change the sign of those 4s, you get -4s. And if I graph these, let's see, x goes out. Okay, so you have -1, -2, 1, 2, 3, 4, 5, 6. 6, 5, 4, 3, 2, 1, -1. And the y values go up to 4 and to -4. 1, 2, 3, 4. -1, -2, -3, -4. So I plot these points. -2, 0 is right here. 0, 4 is right there. 2, 0 is here. 3, -4 is down here. And 6, -4 is down here. Okay, and we got the same graph that we started with, except it's it's negative. Let me just get rid of this, please. Now what you see there, oops, okay, let me erase that. This here is the original graph. That is the original graph. All I did to get the graph over here was flip it over. Instead of being negative from negative 2 to 2, it's positive from negative 2 to 2. And then instead of being positive and then going straight across positive, it's going to be negative. It's negative and it went straight across negative. This is the graph of y equal to not f of x, but negative f of x. You should be able to handle that. Just plot the key points. Plot the key points. Okay, this finishes the video on transformations.